All right, Chapter 6, Section 2. We're going to look at multiplying polynomials in this section. The last section we were looking at what is a polynomial. We looked at degrees, we looked at adding and subtracting, a lot of definition stuff. This one is much more focused, but more math. So, first we can start off with learning targets. The first learning target that we're going to be looking at today is I can multiply polynomials. That one should really be kind of self-explanatory. This is the easier of the two. Believe it or not, you guys have been multiplying polynomials for years now. We just haven't called them polynomials before. The second learning target is I can expand powers of binomials. This is a smaller topic, but probably the harder of the two. And so we'll get to that one second. First, though, let's multiply polynomials. We can start out, big word, distribute. If I had to describe this topic in just one word, it would simply be distribute. So, if we have a monomial times a polynomial, here we have a monomial times a trinomial, we're just going to take this monomial, this whole 3x squared, and we're just going to distribute it to each individual piece of the trinomial. And it doesn't matter how many terms there are in the polynomial, we always distribute it to each and every piece. Remember, the terms are separated by plus and minus signs. We don't take the 3x squared times 2 and the 3x squared times the x squared. It's just 3x squared times 2x squared, which gives us 6x to the fourth, and then 3x squared times 9x. 3 times 9 is 27. X squared times x, we have x cubed. So we have 27x cubed. Remember, when we multiply variables, we add the exponents. And then minus 3 times 6 is 18. And then the x squared goes along for the ride. So we have 6x to the fourth plus 27x cubed minus 18x squared. And that's the answer. That's all we have to do there. If we have a slightly more difficult one, here we have a binomial times a trinomial. Again, we are going to distribute. We're going to take this first term, the 2x, and we're going to multiply it to each and every piece of the second term, or the second number. And so when we do that, we get 2x times 3x squared. 2 times 3 is 6. X times x squared is x cubed. So we have 6x cubed. And then 2x times 4xy. Well, 2 times 4 is 8. X times x is x squared. The y goes along for the ride. Notice it's a minus. So we have minus 8x squared y. And then 2x times 2y squared. 2 times 2 is 4. X times y squared is simply just xy squared. So we have 4xy squared. For whatever reason, I see people that try and take these xy squareds or x squared y, or if we had x squared y squared, and they try and add it to get like x to the fourth y. No. The x's are by themselves, the y's are by themselves. You just smash them together. They keep their own exponents. Don't try and do anything weird with them. So we distributed the 2x to each of these. Now we need to distribute the 5y to each of these. This right here is why I never teach the FOIL method when we're dealing with quadratics, because as soon as you have 3 things over here, that FOIL method breaks down. So just distribute. That's all we do. 5y times 3x squared. 5 times 3 is 15. Y times x squared is x squared y. Yeah, you could put it as y x squared. It's easier if you just put them in alphabetical order, because here we can see that we have 15x squared y and in minus 8x squared y. Those are going to be like terms. We'll be able to combine those in a minute. If you switch the order and had a yx squared, it's harder to see that those are like terms. So let's see, the 5y times negative 4xy. Well, 5 and negative 4 is negative 20. We have a y squared there and an x, so negative 20 xy squared. And then a 5y times a 2y squared. 5 times 2 is 10. Y times y squared is plus 10y cubed. And then from here, we can see that we have some like terms. As I mentioned earlier, we have some x squared y's. So negative 8 of them plus 15 of them is going to give us plus 7x squared y. And we also have some xy squareds. For negative 20 should give us negative 16xy squared. The 6x cubed and the 10y cubed just kind of go along for the ride. They're not doing anything. They just sit there. Then here we have our plus 7x squared y minus 16xy squared. So we combine the like terms. We don't try to do anything funny to combine these. Those are not like terms. X squared y and xy squared are completely different things. And notice, as we saw in the last one, if we have things where these are third degrees each time, just pick one of your variables, x cubed, and then go down, x squared, x, no x. The y's will just be backwards, y cubed, y squared, y, and no y. And so that's a binomial times a trinomial. It's fairly straightforward. It's just distributing. The only thing that can happen is more parts to worry about. So, for instance, if we had a trinomial times a trinomial, it's still just distributing. We're going to take the 4x squared and multiply it to each of these. We're going to take the 3x and multiply it to each of these. And we're going to take the 2 and multiply it to each of these. That's all that's going to happen. So if we start out with the 4x squared, we have 4x squared and 3x squared, that's 12. X to the fourth, 4x squared and 2x is 8x cubed, and 4x squared negative 1 is minus 4x squared. So we just take that 4x squared and multiply it to everything. Now we do the same thing with the 3x. We have 3 times 3 is 9, x cubed. 3 times 2 is 6, x squared, minus 3x. And with the 2, we have 6x squared plus 4x minus 2. And so here, I mean, we have all these things. We have some like terms in there. But as you can probably tell, as these problems get bigger, they're going to get really long across your paper, even ending up way over here. And trying to find our like terms through there can be a little bit difficult. So another organizational method, this doesn't change how we do the problem, it's simply an organizational method, is instead of writing it out like this, we can stack these problems. We took the 4x squared and we multiplied to get these guys. Then we took the 3x and we multiplied to get these. Well, instead of putting them here, let's put it underneath the like terms. So we have x cubes, we have x squareds, then we have our x there that didn't have anything. And we can do the same thing with the product of the 2. We can take it and put it underneath the like terms. And now we can see our x cubes right here. We can see the x squareds. We can see the x's. It makes it really easy to combine our like terms. Again, it's simply organizational, but it makes the problem a lot easier to deal with. And so when we add these up, we have 12x to the fourth. Looks like we have 17x cubes. Let's see, 12x squareds minus 4 is 8x squareds plus x minus 2. And we have our like terms added together. I think it's easier than trying to find them throughout. Also notice when we added these together, we didn't change the exponents. We only change the exponents when we're multiplying. When we add, we just add like terms, we change the coefficient in front. So this is pretty much as difficult as multiplying is going to be. Yeah, you might have a binomial times a quadrinomial. Probably not too much trinomial times a quadrinomial. Maybe one in a challenge type problem, but trinomial times trinomial is really as big as it's going to get. So if you can do that, let's try a couple. We have a monomial times a binomial. That one should be really easy. And then a trinomial times a trinomial. Look, the numbers are a lot easier than these numbers, but the process is still the same. So go ahead, pause this, give yourself a couple minutes to do these, and then whenever you're done, come on back. How do you think you did? Well, the first one should be pretty easy. we have 7x cubed times 2x plus 3. So 7 times 2 is 14, x to the fourth plus 21x cubed. I mean, that's just distributing that 7x cubed. This one's a little bit trickier because we have to distribute the x cubed to get x to the fifth minus x to the fourth minus 5x cubed. Distribute the x squared to get x to the fourth minus x cubed minus 5x squared. And distribute the 1 to get x squared minus x minus 5. Notice this one's way over here offset because it's lined up underneath the like terms. It shouldn't be underneath the x cubed. That's going to confuse you. Well, it has a possibility of confusing you. Put it underneath the like terms, even if you have to skip some. That's where it goes. Well, from here, add them together. We have x to the fifth. The x to the fourths go away. Minus 6x cubed minus 4x squared minus x minus 5. I have 0x to the fourth here. Really don't need that, so we can simplify it to be x to the fifth minus 6x cubed minus 4x squared minus x minus 5. How'd you do on those two? Hopefully the first one was pretty easy. Second one, did you do good? If not, where did you make a mistake? Can you find it? So, binomial expansion. This is the one that's a little bit trickier. When we have a binomial to a power, x minus 3 cubed, say, that's just x minus 3 times x minus 3 times x minus 3. Just like last chapter, we had x minus 3 squared. That's x minus 3 times x minus 3. It is not x cubed minus 3 cubed. Don't be that guy. I always say it, always repeat myself, and yet every chapter, there's at least one person that does it on the test. Don't be that person. X minus 3 cubed is just x minus 3 times x minus 3 times x minus 3, which we could multiply this out. Just take 2 at a time, x minus 3 times x minus 3, and then we'd multiply the other x minus 3 to that answer. That is possible. However, when you have something like a plus b to the 6th, well, if we expand that out, oh, that shouldn't have a 6 on the end there. Oops, just ignore that. It'll go away in a second. If we expand that out, that would be much more unpleasant to try and multiply. So we do have an easier method, and that's called binomial expansion. So we are going to expand these. There's a great formula. We're going to start with this first one, this x, and we're going to make it x to the third power. And then we're going to have x squared in the next term, and then x, and then no x. The second one is going to start out on the other side. We're going to have negative 3 to the third power, and then negative 3 squared, negative 3, and then no negative 3. So it could look like this. We start out with x cubed, then we have x squared, then we have x, and there's no x. And then the negative 3's just go backwards. Negative 3 cubed, negative 3 squared, negative 3, and then no negative 3's. Now, it might look like I've left some room here, and that's because I did. We need what's called the binomial coefficient in front of these. And we get the binomial coefficient from the thing called Pascal's Triangle. You've probably seen this before. I actually have a poster of it right next to my window, but most people have seen it in middle school. There are amazing patterns in this, and it's fantastic. Pascal's Triangle starts out with a 1, and then there's 2 1s, and then each outside is going to be a 1, and the inside number is going to be the sum of the 2 numbers on top. So 1 plus 1 is 2, and then we'll have a 1 on each of the outsides. We'll have a 1, 1 plus 2 is 3, 2 plus 1 is 3, and then a 1. And then we can keep going. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, then 10, 10, 5, 1. Take it out another step, 1, 6, 15, 20, 15, 6, 1. And we could take this out forever. In chapter 11, we'll see a way that we won't actually have to take it out. There's actually a formula that we can get for each of these numbers. But for right now, you're not going to go past 6, really. And so what we're going to do is we're going to look at the row. We have our exponent is 3. Well, the first number is always 1. So look for the second number. We want the second number to be 3. It's this one, 1, 3, 3, 1. We're going to take these 4 numbers, and we're going to put them in front of these terms. Notice we have 4 terms. It's beautiful like that. And so we're just going to put those numbers in front of those terms. 1, 3, 3, 1. All we have to now is simplify. Well, 1x cubed is just x cubed. 3 times negative 3 is negative 9x squared. Here we have negative 3 squared is 9 times 3 is 27. And here negative 3 cubed is negative 27. And so we can just simplify these numbers, and this is what we'd get if we multiply x minus 3 cubed out. And so again, the pattern, we take this first one, start it with the exponent, cubed, x squared, x, no x. And we take the second one, negative 3, start with the exponent, cubed, and go backwards. Negative 3 squared, negative 3, no negative 3. Then we look at the line on Pascal's triangle where the second number matches the exponent. We put it into our coefficients. So let's try that with this next one, a plus b to the 6th. Well, we're going to start with a to the 6th, and then a to the 5th, and then a to the 4th, then a cubed, etc. And the b's are just going to go backwards from there. So start with b to the 6th. Notice when we look at all of these, oh, there's 15 is there. Ignore the 15 for a second. It'll go away in a minute. Notice that each of these degrees is 6. It's the same as this exponent. The degree is always 6. That same thing happens here. 3, 2 and 1, 1 and 2, and 3. And you might be thinking, well, but negative 3 isn't a variable, so it doesn't contribute to the degree. True. That's why I mentioned it down here. But the exponents will always add up to be the same exponent that you start with. So we have our pattern, a to 6, a to the 5th, 4th, 3rd, 2nd, 1, no a's, b to the 6, 5, 4, 3, 2, 1, and no b's. Now we need the line that starts with 1 and then 6, which is the bottom one that we went to. See, there's a 15 that was already there, snuck in there on me. But we can plug them in, and that 15 should have been red too. It's the bane of my existence right now. Anyway, we plug them in, and then simplify. Well, there's nothing to simplify here. There are no common terms, and we don't need to multiply anything out because all of our variables, or all of these pieces are both variables. And so that's what we get. So let's try another one. 3 times 2x minus 4 to the 4th. So here we have a couple things. We have this 2x instead of just an x or an a. This is minus again because I like having that example with that minus in there. And we have this 3 on the outside. The 3 on the outside is just going to hang around until the very end of the problem. We'll distribute it through last. Do not distribute it through right now. If you multiplied it in right now, you'd actually be multiplying in by 3 to the 4th, which is 81. And that is definitely going to change the answer to your problem. So the 3 is just going to hang out in front. And then other than that, we'll start with 2x to the 4th, and then to the 3rd, 2nd, 1, and then none. And the negative 4 will start on the other side. Negative 4 to 3, 2, 1, and no negative 4 here. Hey, look, my coefficients are behaving themselves in this one. So I notice again, the 3 is just out here in the front. It's waiting. Well, let's see. We have to the 4th. So we're going to need the line that starts with 1, 4. Again, notice 5 terms. We have 5 terms. And so we can plug those in. Well, now here we have 1 times 2x to the 4th, 2x to the fourth is 2 to the fourth, and x to the fourth, 2 to the fourth is 16. So we'll have 16x to the fourth. Here, we're going to have 2x cubed. That's 2 cubed is 8, x cubed. And then we'll have to multiply it times 4 and negative 4. Here, 2x squared, 2 squared is 4. And the negative 4 squared is 16. We'll have to multiply by 6. 4 times 2 is 8. And negative 4 cubed. Negative 4 cubed is going to be negative 64. And then negative 4 to the fourth is negative 200, or is positive 256. So we can get our squareds dealt with here, or our powers dealt with. Notice the exponents came into the parentheses, and we actually took those numbers, the 2's to the power. And then we can multiply 4 times 8 times negative 4, 6 times 4 times 16, 2 times 4 times negative 64, to get 16x to the fourth minus 128x cubed plus 384x squared minus 512x plus 256. I wouldn't expect you to do that multiplication in your head. You're going to be using a calculator for that most likely. Unless, of course, you really want to do it in your head. Who am I to argue? Then finally, this 3 on the outside, we just need to distribute it. 3 times 16 is 48. 3 times 128 is 384. 3 times 384 is big. 3 times 512 is big. 3 times 256 is really big. Don't want to think about those right now. But we get 48x squared minus 384x cubed plus 1152x squared minus 150 minus 1536x plus 768. So again, the process is the same. The multiplication got really big really fast and became very obnoxious. You have calculators for that. That's fine. But do you get the process? That's the key. If you think you do, let's try one. P minus 2q cubed. P's and Q's, yeah, they look the same. You're going to have to deal with it. So go ahead and try this one. Pause the video and come back when you're done. All right, how do we think? It should look a lot like this one up here. The numbers are going to be different, but it's a cubed. So first, distribute p cubed, p squared, p, no p, and then negative 2q cubed squared to the first, and none. And we find, hey, look, it's the 1 through 3, 1 again. Plug those in. And then we don't really need to put the 1s on there. And then we can multiply. 3 times negative 2 is negative 6. Negative 2 squared is 4. Times 3 should be 12. And negative 2 to the third is negative 8. So we should end up with p cubed minus 6p squared q plus 12pq squared plus negative 8q cubed, or just minus 8q cubed. So how'd you do on that one? Again, this topic is not as important. Could you multiply them out? Yes. Do you want to? No. If you are of the belief that I'm just going to multiply it out, you need to get really quick at it, because there will be one on the test. And if you spend all of your test time on that one problem, that's not going to be very good for the rest of the test. So I would definitely make sure that you can do this. But again, the first part, multiplying polynomials, is the much larger topic here. So I hope you got this. Make sure you remember what the learning targets are. You can multiply polynomials. You can do binomial expansion. They'll be on the bottom of your activity in class, and I will see you then.